Today we will talk about a walkthrough video of one project on the GCN where I developed a dataset, a graph dataset using some of techniques. You can review it like here. I make a graph dataset using NetworkX. Here is the features, and I have calculated each node feature as a sum of its neighborhood square. Like in this 183 will be a square of one's neighborhood. Like for x index we get only x. This x index of its neighborhood, like node 1 is neighborhood to 2, 3. So here we are squaring 15 plus 20 and 10 and divided by 2. By that we calculated these features or y labels to predict actually what we are doing. So let's start from the start. First we import some important libraries like NetworkX for the network and NumPy when we are doing some array operations, so we need NumPy. And then we have import torch. And in the data part, I have already introduced how we make the data. Let's show you how it will look like. It may be different in your case, but it will have same structure. Like if we run, it's changed. So in your case it will be like this, and in the pre-training phase we will calculate A, which is important in a graph convolution network. Let me find its formula. Here we are only calculating degree matrix and node feature matrix and converting into node features to a feature matrix and y label matrix. You can see later, or you can pause or see, and also I will provide my repo link where you can refer anytime. Here we do min-max scaling, where you can see we are getting global mean and global max and convert into min-max. And we are not scaling the y label, only we do to the feature. And here we are calculating mask or taking masks for the training and testing part. And here we come with model making part where we initialize with two linear layers, initialize with in feature, out feature, hidden layer and adjacency matrix. Why we are passing here adjacency matrix? Because in the pre-training phase we need the adjacency matrix to calculate A here. So here we will calculate degree matrix. After that we can calculate norm, which is this means these two lines will calculate this formula, and here we are converting into a tensor because it's in NumPy array. So we are calculating it init phase because before going to the training phase we already need this A matrix. If you don't understand anything why we are taking this and in the pre-training and we are multiplying in the forward pass, you can refer to my previous video where I explain about graph convolution network. Here in the forward phase we simply multiplying the adjacency matrix or the A into the feature matrix, and we apply two linear layers for the prediction, and here we will initialize our model. Here is input feature is 2, output feature would be 1 because here it is 1, and hidden I have taken 2. You can adjust it in here. In your case you can adjust it, and here we start our writing code for the training part. Here I have taken learning rate as 0.01 and decay rate 5 into e to the power 5 to the power minus 4, and as an optimizer we take Adam optimizer with learning rate and weight decay to update our model parameters, and we start training. Here we pass node feature matrix and a training mask to the model for the training, and we calculate on the loss function only the training mask part. So, and for the test we are taking the test mask and doing the same. Here is epoch size, and in the every 1000 epoch it will print our loss, and here we can see its result, how it predict, like it is our original, and here our model predicted. In the training phase it calculate, it accurately get 241 but nearer to that, and in testing phase it got little bit high. That's it for today. I will provide the whole repo link or this code link also where you can refer anytime you want, and also you can change it. Here I have also provided a little bit big graph. You can show. Okay, so hidden out here. You can show a little bit big graph, but it comes with complexity. When we start to predicting about this node by providing all this node, it will not get much information about here because any neighborhood of it is not connected to it, so it will become more noisy. Predicting this value will be much more difficult. So you can make your own graph data and make some assumptions around that and check is this graph convolution can detect or not. So your task would be you design your own graph data set and try to predict is it getting your induced complexity or not. So you can add this neighborhood information by taking the samples or adding some information of this neighborhood value and see can it get or can it affect, like by providing much higher value here, can it affect those three values? So you can check on that. So if you are curious, you can do training on higher level, and you can also do on the Quora citation network. I have tried, but in here in Graph Convolution Network, it is not fit. Your memory or RAM will be full, and it will automatically stop the training process. So if you have also, you can check Quora with Geometric Graph Convolution Network, and also explore more about, if you are interested, you can explore more architecture. So that's it for today. Thank you.